let us solve a problem from the chapter shaft. So here is the problem definition. Read this definition. So we directly start with the drawing. So what he has mentioned here is the center of the pulley overhangs 150 millimeter beyond the center line of the end bearing. So this is end bearing. So this is end bearing and this is the pulley. So you have to determine the diameter of the shaft, and allowable stress is given, and the pulley weight is this one, W. This is given as 1600 newtons. So this is the proposed sketch, and if they do not give the sketch, then you have to draw like this according to the definition. So now let us see the part of data. See, power is given here 30 kilowatt, and RPM is given, the speed 160 RPM. The diameter of the pulley, that is 1 meter. Another thing has mentioned, T1 by T2 is equal to 2.5, because see here the tension on the tight side of the belt is 2 times that on the slack side. That is tight side and slack side. You might be knowing the smaller side and bigger side. This is a slack side and this is tight side. So that is the concept here. So tight side to slack side ratio is given. So tau max it is. Wait. Next, solution. The torque transmitted that is available in the page 42, equation number 3.3e. See, I have referred the third edition design data handbook. The page number may vary in fourth edition. This may go to 48, page number 48, and this equation is 3.3e. You can see that, and some of the equations are having some errors in fourth edition. Please refer with the third edition and correct it. So this is the equation, T equal to 9.55 into 10 to the power 6 P by N. So this is the substitution. 30 is the power here written, and 160 is the RPM that is written over here. That is, so you'll get the torque as 1790625. After getting torque, now for belt drive, you might have gone with this equation in some other subject. It is there. So T equal to T1 minus T2 into R. That is, T1 and T2 are not given. T you have calculated, that is torque transmitted, and R, this diameter is 1000 and the radius will be 500. So the next thing is substitution. Substitution is done. Now calculate T1 minus T2 is this one. This is what value you get. But what we have gone through is the tight side to slack side ratio is 2.5. So tight side to slack side ratio 2.5. That means we have to cross multiply this. That will be T1 equal to 2.5 T2. So substitute this one, this value here. Instead of T1, substitute this value. So you will get the T2 value later after calculation. So after substituting, you can add substitute T2 value here, and you will get the T1 value. The total downward load acting on the shaft due to belt drive, that is, see here, total downward load acting on the shaft. Okay, so this is T1 plus T2 plus 1600, that is of this one, which one, the load acting, the pulley weight. So the pulley weight is 1600. So after that we'll get this one. So next we have to calculate bending moment. Okay, I show you the bending moment. So from this way, from this side, we are calculating bending moment from B to this one, like this. So bending moment at B is 0, and the bending moment at A, that is the value of total downward load into 150, that is the distance, 150 millimeter. that we have to check. So we'll get this value. So since the bending maximum bending moment, it is the positive, so it will be positive value. We have to take sagging and hogging. You might be knowing that sagging and hogging will go plus, and this one next minus. According to the maximum shear stress theory, see this equation here they have given for hollow shaft. Hollow shaft means this is hollow shaft, but now we are having only solid shaft. So for solid shaft I have made modification here, because k will be 0 because it is a solid shaft. For hollow shaft k value will be given. For modification, as a part of modification, I have done this as d, so that you can understand better. So k is 0 anyhow. So when k is 0, 1 by 1 is 1. So forget it. So this equation is available in page number 43 in third edition, and 3.6a is the equation. So later we will now substitute the values. Okay, so we have to have cm and ct, which I have shown you in the equation. You can see cm and ct are there. Here cm and ct, that value must be determined. So where will we get this? That is table 3.1, page number 47. In the page 47 we will get this value. See, they have given let us consider suddenly applied loads, minor shocks only. So minor shocks we are considering. So cm I have taken in between value, ct I have taken 1.25. so in between values. So substitute this and you will get d value. So after that, standard diameter of the shaft we have to calculate. This is the obtained value. You can write this, no problem, or else you have to determine the standard diameter of the shaft. That is page number 48 in third edition, table number 3.5a. You will come to know after 66.35, the immediate next number is in the data handbook is diameter equal to 71 mm. So this is the standard diameter which you had to calculate. Thank you.